Time, a concept that is so ancient there is only one thing that as old as time, space. Time affects all things in the world, and passes in exactly the same way for all living and inanimate things on Earth. Humans and more intelligent animals can perceive time subjectively, which differs from objective time in a way that no one but the perceiver cares about it. Unfortunately, it also has the bad habit of passing at the opposite speed of the speed you would like to do so. During more complex banking procedures, the minutes feel like hours. And after 20 minutes of playing Baldur's Gate 3, you realize that it's already tomorrow morning, and you should have been work at 3 hours ago. So even reality, time is a strange thing. But how does it work in video games? To set up a system, we first need to look at physical board games. Classical board games typically manage time differently from reality. It's your opponent's or your ally's action that decides when you can move, not the seconds that have passed. If you take a 1-hour break during the game, nothing in the game changes when you return. Video games can have a variety of time management, which can be placed on a scale between reality and board games. In Doom, time passes pretty lifelike, because if you walk away from the PC, the IMP gang will chop your ass up in seconds. Unlike the previously mentioned Baldur's Gate 3, when the passage of time is almost entirely determined by the player's actions both in and out of combat. Time passes naturally in Enslaved the Awakening, with 24 hours of days alternating at an accelerated rate. This is controlled by a clock that accurately tracks time and gives the proper signals when it changes. The other objects in the game either watch this clock or their behavior can be tracked back to it. NPCs sleep, wake up and work when the clock tells them to. This is what we are going to create now. Let's create a node to the object with a timer inside. Although this will be the soul of our clock, we need to add many things to it. We will also add the labels so that we can keep track of the time changes. We record these as variables. We create two export variables, hour length and starting hour. As their names suggest, the former specifies how many seconds an hour should last, and the latter specifies what time should be in the game when it started. After that, we create other variables like day length and current time. We create an hour change signal, which sends signal at the start of each hour. Then, we can start writing the ready function. To the day length variable, we pass the following value, 24 times the hour length variable. Then we do a check to see if starting hour is within the desired interval. We give the current time variable the value of starting hour, then print the same value into the label and call for the hour changed signal. Now that the initial status is set, let's start counting. The timer is started by subtracting the starting hour value from 24, producing an inverse value, and then multiplying this by the hour length value. If starting hour is 0, then timer is started with the value of day length, which is equal to 24 minus 0 times hour length. Does your head hurt yet? And the best is yet to come. We create the process function, which is responsible for monitoring the timer and returning a signal at the proper moment. Brace yourselves, this is not going to be an easy ride. So the timer counts backwards, in seconds and fractions of a second. First, we need to signal when the whole part has changed, that is, when the remainder of the timer's current time divided by hour length equals 0. But this is not enough, since the function would then run more times for each change, because the timer is simply slower than that. We need to check whether it has already run in the current hour, by the checking that the label text is equal to the current hour. If not, we only let the if section run. By the way, the current hour is calculated like this. No, don't ask. Once you have that, the hard part is over. Within the if section, the first thing to do is update the label text to the current hour, and then handle the clock loop, which is essentially if the current hour is 24, then we immediately set it to 0. After all, we call for the signal. A clock object is created, in which you can specify the length of the hour alongside with the starting hour. It can easily be extended later to count days and months, but that's another story.